All right, today for geometry we have lesson 3.4. We're talking distances, midpoints, and slopes. All right, so let's jump in. First of all, we have the Cartesian plane. A few things. You should know your x. Sorry, I thought I had my pen out. Handy dandy pen disappeared on me. All right, you should know your x-axis, your y-axis, your origin, and that when we number the Cartesian plane, they have quadrants. There are 4 quadrants, 4 sections. Quad means 4. Starts in the top right, and then it goes left. So quadrant 1, 2, 3, and then quadrant 4 is your bottom right. It's totally backwards, not how normal things are ordered, or, it's definitely counterclockwise in the naming of it. All right, so an ordered pair of coordinates is always your x comma y inside the parentheses, and your origin is always that 0, 0. So I'm sure things that you are perfectly aware of, but just wanted to check. All right, we're going to be focusing a ton today on this distance formula. Okay, that's why it's distances, midpoints, and slopes. Okay, so the distance formula is going to tell you the distance or the length between any 2 points. All right, so if we look at this triangle, here we have points A, which is here, and its coordinates are x1, comma y1. And point B, let's slide that over just a little bit so we can see it, okay, is the coordinate of B is x2, comma y2. And so B is here. So we can use the distance, we can find the distance of any 2 points. So we can find the distance of A to B, from A to C, and from C to B. Okay, any of those distances. A is not very hard because we just find the difference between our x2 and our x1 value. We just subtract those. Okay, B is not very difficult because we can do the same thing. We find the absolute value of the difference of y2 minus our y1 value. So the distance here. Not bad. It's that hypotenuse or that diagonal distance where we need this distance formula. Okay, so the distance formula is the square root of x2 minus x1 squared plus y2, the quantity y sub 2 minus y sub 1 squared. Okay, so we're replacing numbers. We're going to substitute numbers in for every part of this to solve for the distance. So in example 1, it says to find the distance between negative 2, 5 and 4, 1. I'm going to slide that up. So we're going to use that formula, and we're just going to plug these numbers in. So since this is our first set, it's going to be our x1, y1, and 4, 1 is going to be our x2, y2 values. All right, so let's plug them in. Distance equals the square root of, we're going to subtract our x's. So 4 minus negative 2 squared plus, that's what comes next, the difference of our y's. And again, we have to start with our y2. So 1 minus 5 squared. Let me extend my square root sign. Okay, so this is going to equal the square root. 4 minus negative 2 is the same thing as plus. So this is going to be 6 squared plus 1 minus 4 is negative 4 squared. And yes, I should see this step. Okay, I know it's one that sometimes we want to skip, but I want to see it to make sure that you're doing your addition right. So this equals the square root of 6 squared is 36 plus negative 4 squared, because all that's inside your parentheses. So negative 4 squared is 16. All right, and that equals the square root of 52. Okay, but like last week, we need to simplify our answer. So one, there's a couple things here. I want to know you know how to do this process, okay, and using this distance equation. The other thing is remembering from last week when, hold on, we did not do this last week in your class. So you may not be very good at this. Okay, so I will accept this today. Or you can put it in the calculator and you would get that it's approximately 7.21. But notice you need to make sure you're talking approximately. The square root of 52 is exact, but in my Algebra 2 class we talked about reducing square roots, which we haven't done in this class. So I'll pass that on that for a moment. All right, the next formula that we're going to use is the midpoint formula. Okay, so we're going to use it to find the midpoint of the segment with endpoints x1 and y1, and midpoint of the segment B, or endpoint B, which is x2, y2. And so all we do here, M stands for midpoint. So our midpoint is the addition of our x values divided by 2. So it's really the average. And the same with our y's. We add our y values together and divide by 2. And that's how we get our midpoint. It's finding the averages of the midpoint. Okay, so let me clear our page and move it up. Well, if it'll clear, if I hit the right button. Okay, so we could do examples 2 and 3. Example 2, find the coordinates of the midpoint of xy, given x is -2, 3. So that's going to be our x1, y1, and y is 1, 5. So that's going to be our x2, y2. All right, so we just plug them in, we substitute them into the formula. So m equals, or m is, there's no equal sign there, and we just go to work. So we're going to add our x values. So -2 plus 1 divided by 2, comma, and we're going to add our y's. 3 plus 5 divided by 2. All right, so -2 plus 1 is -1/2. And 3 plus 5 is 8. So this is going to be 8 over 2. Okay, so our first point is fine. It's already reduced, -1/2. 8/2 we can reduce though. Yeah, that's just 4. Whoops. Let me erase here for a second. It's -1/2, comma, and 8 divided by 2 is 4. So those are the coordinates of our midpoint, -1/2, 4. Example 3 says find the coordinates of B if M, and remember this capital M stands for midpoint, so the midpoint is -1, 1/2 is the midpoint of AB, segment AB, and A is at -3/4. Okay, so the first one says to use the midpoint formula and then to solve the equations. You're probably wondering, like, why would I use the midpoint formula? I already have the midpoint, Mrs. Talbert. However, we can use that formula to help us get equations for the other point. So we're going to use it backwards. So let's do the midpoint formula. Remember, so it's this one. So we're going to have x, because we don't know, here's our, let's see, these are x1 and y1 values. Okay, so let me go back over here and start over. So we're going to say our midpoint is -3 plus x divided by 2, comma, and then our next one is going to be our y values. So we're going to have 4. So 4 plus y divided by 2. All right, so we've got our midpoint formula there, but we also know what it's equal to, right? Because they told us the midpoint right here. So we're going to say that's equal to -1, 1/2. Okay. So now we can take this and kind of part it out. Okay. So this -3 plus x divided by 2 goes with this -1. So I can set those equal. -3 plus x divided by 2 equals -1. While at the same time, I know that this part of the equation goes with the coordinate 1/2. So 4 plus y divided by 2 equals 1/2. And I can solve each of those separately to get my coordinate. Okay. So first of all, I'd multiply by 2. Okay, so both my denominators on both sides here, right? Both my denominators would cancel. So I would get 4 plus y equals 1 minus 4. So y equals -3. Hopefully you can see that on the black. So y equals -3. Let's see how this green looks. Not so grand. Let me see. I'm going to put, here we go. I'll put some white paper under there. Kind of gives us a bit of a shadow. That's a little better. There we go. That way we can at least see it and solve. Okay, so for this other one, I'm going to multiply by 2 as well to get rid of this denominator. So my 2's cancel. I'm going to be left with -3 plus x equals -1 times 2 is -2. I would need to add 3 to both sides. So x equals -2 plus 3 is 1. So there's my x value is 1. So it says find the coordinates of B. So B is 1, comma, -3. So that's kind of a fun one, I feel like, a little more complex, maybe a little more algebra than we usually do for geometry, praise the Lord. But we can definitely use that midpoint and make connections there and use it to the best of our abilities. All right, let's flip over to the back side. Talk about some slope here. Okay, so slope is the ratio of a line's rise, so the vertical change, to its corresponding run or its horizontal change. You'll see me use that delta or triangle for change a lot. Okay, so slope describes a line's steepness. All right, so again, if we look at the graph here, we can see we have our rise. We have a couple points picked out. So here's one point and here's the other one. So to count our rise, we went up, and we can see we went up 3, and then we ran over a +2. So in this case, our slope equals 3/2. Okay. So oftentimes, we talk about slope. We talk about it as the rise over the run, or y2 minus y1 over x2 minus x1. And you'll also see me write it as the change in y over the change in x. It's a little bit quicker, so you'll get all of those from me. And then there's a couple different types of slope. All right, so the first one has a positive slope. Okay, so that's where its rise goes up and its run goes right. A negative slope, okay, is, let me go back here and put positive and positive. A negative slope, if we look at it, the rise goes down and then we can go right, but this one has to go down. It has one negative. So it has a negative slope because one number has a downward direction, or it could have a left direction. It could be up. That's the other thing that's about those, right? Is it could go up, which is positive, and then have a left direction, which is the negative. Got some Christmas colors going on there. Okay, so either of those ways you want to look at it is negative. All right, the next one is a slope of 0. We might say no slope. It's a horizontal line. And the last one is an undefined slope. It's vertical. Okay, so we don't know what its slope is. We can't define it. Okay, so let's look at example 4 and find some slope. All right, so example 4 says find the slope of each line. Well, A, we have a graph, so that's pretty awesome. Okay, so we can pick 2 points on our graph. They're actually already given to us. One is here, and the other is there on the origin. So remember, slope is rise over run. So how many we go up? It's not wanting to write. There we go. So we went up 1, 2, 3. That's a positive. And now we're going left 1, 2, 3, 4. So a -4. So my slope is 3, -4. Or you can write it -3/4. The negative can kind of be out front. Either of those is totally acceptable way to write it, but it's -3/4. And it matches the graph above that has a negative slope. So you could be like, oh, yep, it looks like a line with negative slope. That's good. All right, B, a line that goes through 1, -4, and 3, 2. Well, we're going to have to use that change, right? M equals the change in y over the change in x. Okay, so our y values are -4. So we do -4 minus 2 over 1 minus 3. Okay, or that's the other thing with this one. You can do these in any order because the formula actually says y2 minus y1. So you could do 2 minus -4 over 3 minus 1. All right, so either way, let's check it out. If we do the first strategy, -4 minus 2 is -6. 1 minus 3 is -2. They both have a negative, so it's positive. So the slope is equal to 3. If I do the other way, where it's y2 minus y1, x2 minus x1, 2 minus -4 is a positive, so that's 6. 3 minus 1 is 2. 6 divided by 2 is 3. See, either way, the slope is the same. Okay, so it doesn't really matter which order you subtract them in or find the difference, because now you can work with positive and negative numbers. So it's going to get the same either way. All right, a couple of postulates for us today. The parallel slopes postulate says non-vertical lines are parallel if and only if they have equal slopes. Any two vertical lines are parallel. Ooh, that's like a nice little caveat. So there's like two postulates in there. Any two vertical lines are parallel because they're all undefined. But if they have an equal slope, then you know that they're parallel. Okay, so the perpendicular slopes postulate. Non-vertical and non-horizontal lines are perpendicular, okay, if and only if the product of their slopes is -1. Then there's another little caveat there. Any horizontal line is perpendicular to any vertical line. So there's kind of two things there, again, in that postulate that you can use to prove. All right, then it says notice. So this is kind of in simpler terms. The slopes of perpendicular lines are opposite reciprocals. Okay, that's what it says because they have to equal -1 of each other. So 3/4 is perpendicular to -4/3. So notice we flipped, right? The reciprocal of 3/4 is 4/3, and then we had to add the opposite in there. So the opposite reciprocal. And then the next one was, slide it over, 1/3 is perpendicular to -3. Okay, so we switch these because it's 3/1, and then we had to make it the opposite. Because if we multiply those, 1/3 times -3, right, the 3's cancel. So 1 times -1 is -1, and that's exactly what we said we had to have. The slopes of a perpendicular line have to have a product of -1. The product of their slopes is -1. Okay. Not much to write down today, really. All right, last example is example 5. Use the following points to determine whether each pair of lines is parallel, perpendicular, or neither. And so we've got our list of points there from A, B, C, D, and E. So if we want to know if they're parallel, perpendicular, or neither, we need to know They're slopes, right? Like we need to know what the slope equals on each of these lines. All right, so let's find the slope of AB. So the slope is m of AB. All right, so I'm going to circle A and B to get me started. You may not want to. You might want to put your fingers on them or whatever because we're going to be circling a lot of things. All right, so the slope of AB though. So it's the change in our y values. So 4 minus 2 over negative 3 minus 3. 4 minus 2 is 2. Negative 3 minus 3 is negative 6. This reduces to negative 1/3 for the slope of AB. All right, so now let's do the slope of CD. All right, so I'm going to erase, or maybe let's see, I'll do these in a different color. All right, C and D I'll do blue. So let's change this. The slope of CD equals. All right, for that I'm going to do 4 minus negative 3 over 1 minus negative 2. So 4 minus negative 3 is the same thing as 4 plus 3. Oh, hold on. I'm sorry, that's negative 4. There we go. That's better. So negative 4 plus 3, negative 1. 1 minus a negative is going to be plus. 1 plus 2 is 3. So hey, let's check out these slopes here. Okay, so we have negative 1/3, negative 1/3. Go back to those postulates. And what do we know about these lines? Are they parallel or perpendicular or neither? All right, they're parallel. Okay, so this means that they're parallel. Okay, because same slope, and that's the parallel slopes postulate is our reason. Okay, so there's our statement and our reason. Next one, AE and BC. Okay, so now I'm going to erase some of our circles up here. Sorry if you hear that squeaking through the camera or through the microphone. Okay, so AE is our first one. So let's circle A. Still got my eraser. Doesn't do me any good. All right, so let's circle A and E, and let's find their slope. So the slope of AE equals 4 minus 3 over negative 3 minus 0. 4 minus 3 is 1. Negative 3 minus 0 is negative 3. All right, so we got negative 1/3 there. And let's do the next one, BC. Wait, did we have a BC earlier? No. Okay. So slope of BC equals 2 minus negative 4 and 3 minus 1 in my denominator. So 2 minus negative 4 is plus. 2 plus 4 is 6. 3 minus 1 is 2. 6 divided by 2 is 3. Okay, so our slopes are negative 1/3 and a positive 3. Well, they're not equal, so we know it's not parallel. So we need to check if they're perpendicular, and if they're not, then it's neither. Okay, so remember at the perpendicular slopes postulate, the product of the slopes is negative 1. So if we took negative 1/3 and multiplied by 3, okay, our 3's would cancel. That would give us a 1. Negative 1 times 1 is negative 1. So hey, the product of their slopes is negative 1, so these are perpendicular. Okay, and that's the perpendicular, just like the parallel slopes postulate, this is the perpendicular slopes postulate, is the reason. Okay, we can conclude that they're perpendicular because of the perpendicular slopes postulate. All right, then you've got 4 on your own problems there, and the homework assignment is on the front. So I hope you guys have a great day. and I will see you tomorrow. Good luck on your homework.